Hello guys, this is Ruby and I'm so excited to meet you and teach you today. So today's agenda is binary search algorithm. So like how much excited are you? I want to know. And trust me guys, bear me for like 20 minutes of timeline and I will teach you what binary search is, what is its complexity, what is space complexity of it, and how to write binary search code and practical examples with driver of the code. So let's get started. I'm excited. So, what is an algorithm? What do you think is an algorithm? Have you ever tried to do your homework, like in your childhood? Or maybe have you ever tried to complete your assignment? Or have you ever tried to perform any of the tasks? So, to perform any of the tasks, there is a process. That process itself is algorithm. So, algorithm is just a process. Follow these steps and you will get this. Do DSA, you will get into good companies. It's like that. Okay, so an algorithm is a step-by-step procedure or a set of instructions to solve a particular task. Okay, so did you understand? Just give me +1 in the chat and we will move on to the next and our main topic, which is searching. So name itself suggests that we need to search something. Okay, so there are two types of searching, mainly linear search and binary search. Don't worry, we are going step by step. So did you understand searching? Yeah, I think it's basically searching something. Like we will see what are we searching and all, but we know what is the meaning of search for now, right? So it is an algorithm, okay? Like people have made it early. So now there are two types of searching, okay? One is linear search and second one is binary search. These are the types, or maybe you can categorize it, right? So linear means straight. We know that something is sequential here. So when you like search one by one, one by one, one by one, one by one, and try to find out your target, that's linear. Binary is something different. Let me take you to a world of shopping mall. Okay, so let's say in the shopping mall you have all the things stored in a sorted order. Okay, and you are very hungry and you want to like grab uncle chips very quickly. How will you do it? Think. I'm giving you time to think. So like first thing is, any guesses? Okay, let me walk you through it. One thing, a person can go check one item. No, this is not Uncle Chips. Check another item. No, this is not. This is not. This is not. He will go sequentially and he will search in the whole mall that where is Uncle Chips. Second option is very cool, which is we already know that all the elements, all the things are present in the sorted order, right? So what we can do is we can just go through the shopping mall and since we know that it is Uncle Chips, it starts from U. So we don't have to go through the A line, B line, C line, and so on. So what we are going to do is we are divide our search space. We will go somewhere in the middle. We will find out like somewhere in the middle. I think 26 by 2 is like normally practically you will go somewhere in the middle and then you will see like, oh, is it the letter which I'm close to, which I'm searching? Like you will find something like 11. Oh, I don't know. We can just divide and check 2 under 2 and 13. So 13th number alphabet is something A, B, C, D, E, F, G, H, I, J, K, L, M. So you will find out M. I was correct. So M, is it U? No, it's not. So you will go search on the side of right hand side of M because you know that your uncle chips can never exist on the left hand side, right? Now, finally you will find it and you will check it, grab it. So what do you understand? Even we can take an example of dictionary. If I say you search for word happy, how are you going to search it? Will you search it from the starting, like for all the A's, B's, C's, or will you go like divide your dictionary into the half because you already know that the dictionary is sorted, right? You're gonna divide it. So that's what we are going to do in binary search. And since we are dividing it, so it will take less time than what linear is taking. What linear is doing, it is taking big of n time because we are going through each and every element. Okay, let's say there are n elements and we are going through all the elements. But what about binary search? Since it is taking half at every iteration, the time complexity will be bigger of log n. But we are gonna see it. Just wait for a couple of minutes. We will directly jump into this. But before jumping into this, we will see what binary search is. So I think you have a naive idea now that how are we going to do it? We are gonna divide our search space and we are gonna go in the direction where we can find out targeted value, right? That's what binary search is. So here I've written some defines and steps for you guys on binary search. So binary search is applied on a sorted array, always on a sorted array, right? Because that's how you will search the element. Instead of checking for every element one by one, like linear search divides the array into two halves and focus on the relevant part. That's what I said. Okay, so we are going to start with a sorted array here. Like, let's say this is a sorted array. Okay, so we are going to start like this, and let's say we are finding our number 8. Okay, how will you find number 8? Tell me. You'll go in the middle, right? So what is the middle? No, this is not middle. This is not middle. 1, 2, 3, 4, 5, 6, 7. 7 by 2 is 3. 0, 1, 2, 3. I think 8 is the middle. And you are lucky that you found 8 in the middle. Okay, so what if I say, like, can you find me 12? How will you find it? It's simple, right? You will check what is the middle element. You will find that 8 is the middle element. And now you know that 12 is greater than 8. So you will proceed ahead on the right hand side. That's the bare minimum thing here, okay? Now we will jump straight into what is binary. So this is indicating low pointer and this is indicating high pointer. Okay, now let's say, so first thing was we made sure the array is sorted array. Okay, so we have written down the indices. Okay, now what to do next? We have low pointer, high pointer. We don't really care about steps right now. We are just worried about how to solve this. We just want to find an element. This is a sorted array and I want you guys to find out 4 to me. With these eyes you can find it out, but in the computers how will you find out? So you need to check one by one, but we know that one by one is linear and we are using binary search. How to do it by using binary search? Can you think of? Yes, we will take the same example we were using in the mall or for the dictionary purpose. What we were doing there, we were dividing the search space into the half and we were finding out the middle element. That will make our task easy. That's what we are going to do. So here, what is the middle element so far? So what is middle? We can just simply take this index plus this index. I will just mark it quickly. So we can take this index and this index, okay? These two indices. And then we will just divide these two indices, 0 plus 6 by 2. It's probably 3, okay? So now we know that 3 is the index, which is my middle index. I will just quickly change my marker pen. So now that I know that 3 is my middle index, what to do next? Come on, guys. Any ideas? Yes. So we will check whether at index 3 my target value is present. What is the target value? I'll just write down my target value here. Oh. So I want you guys to find out 4, but you found out that middle element is 1. One third index, one element is present, right? The element 1 is present. So that is not equals to 4. So what will you do? You do not find like Uncle Chips at M letter. What did you do? You moved on to the right space. That's how you will do it here. So 1 is really lesser than 4. You will move on to the right space. You want to find 4. Now, to move to the right space, what are you going to do? You will shift your low pointer to mid plus 1 here, right? Because we have checked till here, we have checked. So my search space is 2, 4, 5, which is a little lesser than what we think. So it's 2, 4, and 5, right? But then this will be same, right? Because we are doing it in the same array. Now here you are going to do again, like this is your low, this is your high. Target is 4. You want to find out 4. How will you do it? You will find out is my middle element, which is 4 plus 6 by 2, which is 5, right? 10 by 2. 10 by 2 is equals to 5. So now that you know that 5 is my middle element, right? I hope you are getting the point and I really think that you got it. Right? Correct. So this is my middle element. And yes, it is equals to my target. So I will return that at index 5. I have found out 4. It's as simple as that. Now we will jump straight into what I have written here. Okay. So here we were concerned about 8. We found out 8. We returned it and we said that yes, this element is present in the array. Okay. Now, I want you to find me 12. How will you do that? You will find out the middle element, that was 8. No, this is not the middle element. So you will search in the space 10, 12, and 14. Here again, you will do all those steps. And once you find out that 12 is your middle element, you will just return it. Simple. Okay. One quick question to you guys. What if I ask you to search for 13? How will you do it? 13 actually does not exist. How will you do it? So you have to ask the interviewer or whoever is giving you the question that, or like in the question, it will always be mentioned that please return -1 in case the element is not present. Okay. So you will search. We will take this array as an example and we will search for, or maybe we will take this array as an example. Any array is fine. We just want to do things. 0, 2, 4, 6, 8, and 9. This is my array and I want you guys to find what? Yes, find 13. Can you do it? With a naked eye? Yes. This is our target. You need to find out. How will you do it? Again, the same procedure. You're gonna go ahead. This is your low pointer. This is your high pointer. You will mark them. This is 0, 1, 2, 3, 4, 5. So 5 plus 0 by 2, it's 5 by 2. This is the middle element. Now, is it equals to 13? No. But is it greater than 13? Is it smaller than 13? It is smaller than 13. So I know that all the elements towards the right will always be smaller and I don't need to check here. I will check here and shift my low here because I know that till middle I did not find it. So 13, are you? So 13, are you here? Okay, let me check. Come on, we will again find out the middle element, which is 4. Now that I know that middle element, it is still lesser than what we imagined. So I know that this won't be helping me in finding out my thing. So this is also not the case. Now I will move ahead. This low will come here. Okay, mid plus 1. Now low plus high by 2 will be 5 only. Middle will be 5 and this will be the middle element. And now that we know that 9, are you greater than 13 or less than 13 or equals to 13? So 9 will say that I am lesser than 13 and that's how you know that low pointer will somewhere point. Here was middle and here we had high. Low pointer is somewhat here and it has crossed the boundary so that now we know that 13 does not exist and we will return -1. A quick example, I also want you to go through one edge case which is really important and that is what if 0. This is the only array and I ask you to find 9. So will you apply binary search here or you will just, because this is like one element. So you can consider it in a situation of like if statement where you will just write a condition and like if array has one element, just uh, check whether it is equal to the desired value or target or not. If it is equal to the target, return true or whatever the element, whatever the question is asking. Otherwise, don't return or return -1. Okay. So I think we have covered the edge cases, the binary search algorithm, and the dry run. Okay. So when you will go from here, you will know that all these steps are being followed correctly. Just go through it after the class. Okay. Now I want you to. I just want this array quickly again. So I will just move towards here to make sure. -5, -2, 0, 1, 2, 4. So guys, this is the waiting time. You can ask me questions if you have any questions here, and you will also know that. Yeah. Are you finding it easy? Do you have any doubts? Do you want me to do anything? Any of your examples? Just let me know, okay? Yeah. So this is low pointer, this is high pointer. We are marking the indices here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Any doubts till now? No. Right. If you have any doubts, just comment down. I will make sure that I reach down to that comment. Okay. Now here, what is the middle element? Quickly, 9 by 2 is 9 by 2 is 2 4s 8. Yep, this is the middle element. The target is to find 7. No, let's find minus 2 because I want to high to move also to take you to another example. So our target value is minus 2 and we are going to through this array. Okay, now what do you think should be the solution here? Yes, again we will repeat the same procedure. Now that you know, let's go through it together. Is it equals to minus 2? No, it is definitely not equals to minus 2. What are we going to do now? We're just going to change the marker to avoid, the mess. Okay, so this is not equals to minus 2, but now that I know that this is uh, like greater than minus 2, so I definitely need to move towards the left hand side of the array. Now, I will just move my high pointer towards mid minus 1, okay? So, instead of like doing it in the same array, I'm doing it here. And I will tell you why. Minus 5, minus 2, 0, 1, okay? Are we considering 2 here? No, because we already checked it, right? So this is my left pointer, this is my high pointer now. Why? Because we have moved this high to this position. And now that I know this is my search space and this is the other half of the array, which is 2, 4, 5, 6, 7, and 10. Okay? Guys, come on. So we have divided this array. Now again, we are searching for minus 2, okay? So what are the indices here? What were the indices here before? 0, 1, 2, 3, okay? We are concerned about these indices right now also. We are gonna just change our marker because we don't want this color now. Come on, let's just find out the middle element, which is 3 by 2. Low plus high by 2, which is 2 1s are 2. This is my middle element, okay? So far, I have found my middle element. Now what? I'll make the array again. And now that I have found the array, is it any sense to make the array? No. Because I have found my element and I will return it. Straightforward thing, okay? So, like I have divided my array into, let's say, no, I don't want you to find out minus 2. I want to find out minus 5. What are you going to do? Target is minus 5. मेरा मन नहीं कर रहा है. And now I want another snack. This is minus 5 and I want to find out what is minus 5 here. Does it exist in the array or not? So we were like dividing the array. Now we know that this is minus 5, okay? So I'm writing down the indices here. Is minus 2 equals to my target? No, it's definitely not, but my target is lesser than what we have to find. So let's say I put it as low, this one as high. We want to find out the middle element. The middle element is this minus 2 here. So this is minus 2, which is middle, but I want to shift my high towards this because my minus 5 is lesser. So we will shift down to the left hand side. Now what? Again, what we just did, I want to know. So we divided the array again and now we have this element. So what are we trying to do? We have divided it into like half. Again we have divided the array into half, two sides, right? One side is this and second side is this. So the idea here is, let's say there were n elements, right? And then we divided it to like n by 2. We further divided this n by 2 into two pieces, which was n by 4, which will become n by 4, right? Because dividing it by 2 will give us n by 4 and so on. Like this will give us n by 8 and it will continue. So do you notice any pattern here? It is n by 2 to the power 0 is 1, right? 2 to the power 1, this is 2 to the power 2, 2 to the power 3 and so on. This is how the pattern is going. So we can we say that it will go on until one element is left, right? 2 to the power 1 is 1, 2 to the power 2 is 2, 2 to the power 3 is 3, and so on. This is how the pattern is going. So we can we say that it will go on until one element is left, right? 2 to the power 1 is 1, 2 to the power 2 is 2, 2 to the power 3 is 3, and so on. This is how the pattern is going. So we can we say that it will go on until one element is left, right? Can we write it like n by 2k? Yes, we can definitely write. So we will go on till it becomes 1. So for further analysis, what we will do, n will be equals to 2 to the power k, okay? And what is 2 to the power k? What if I shift this towards this side? It will become log n. And that's how you find out the time complexity in binary search. Isn't it amazing? It is. So I just wanted to teach you this thing so far. And I've already written everything which I just said. Okay? Like the time complexity of binary search, how do you find out? How do you do these things? I've written everything down. So what about the space complexity? Did we take any space? We took low pointer, we took high pointer, and nothing else. And we took middle pointer also. Is there anything else we did take? No. And for variables, the space complexity is big of 1, so we don't have to worry about that. We did not take any space. Since we did not use any kind of recursion here, right? So we did not use any stack space. But if you want to do binary search with recursion, then you will take up the space complexity as the stack space. This is just additional information, but try to do in like iterative way. Iterative ways like using for loop and avoiding recursion, and that will be more helpful to you. And now let's get into, I've already explained all these things, and I think so far by now you have like little idea about what binary search is. I am pretty damn sure that you know the definition. So let's combine all these things together and let's get into the pseudocode, and we will try to write code for it. After that, we will jot down our thoughts to be clear with all things. Okay, just be with me for a few more minutes. Okay, so can you see the screen? Pseudocode. What is pseudocode? Like what I have to do in code, I've already written it. I've not used any of the programming languages for it, but I've just written down the steps and pseudocode. Okay. So like how will we start? We will take a loop pointer or maybe a start variable. We will take an end variable. Like we started with the first element in the array and last element in the array. And then how will we proceed? We can take a while loop or maybe a for loop. Anything is fine. We are using while loop here. Let's get ahead. We want our loop till when? Till they crosses each other, because if both of the pointers cross each other, we know that there is no possibility that the element exists. If it had existed, we would have found it. So we know that we are running the while loop. Now, what we did is take the low pointer, high pointer and divide it by 2. That's what is written here. And we will check whether the middle element is equal to the target or not. If it is equal to target, we will return the middle. And if it is greater than the target, if the middle element is greater than the target, we are going to go towards the left hand side. And if it is not greater than the target, we are going to go towards like left hand side and right hand side. Oh, I think we have to iterate it again. So what did I just say? If my target is greater, okay, then I know that I have to move towards right hand side. So I need to move my low pointer towards mid plus 1. And if I know that my target element is lesser, I need to go towards my left hand side, which is I need to move my high pointer towards mid minus 1. Okay. What if after doing all these things, I will just simply return minus 1. There is no point in searching them. Okay. So guys, we are going to see the code now. So the code is in C++. Okay. Since I like C++, but you can write it in your own language, whatever you choose to do. It's just you need to know the algorithm and you are fine with anything. And trust me, you will be able to write after the class gets over. So I have written this function array target and the number of elements. Let's go to the main function. So first thing is we want an array. We want a sorted array. So like we have written this sorted array. We can also take it in the vector, but it's fine. So we have taken n number of elements in the array. I have written it like this, but we can also, when we take the vector array, we can just take the array dot size and it will also work. Okay. Now the target we want is 10. So we have to find out that 10 is present in the array or not. If 10 is present, then at what index it is present. That's what I need to find out. Okay. If the result comes as -1, I will print that element found at. Okay. If result is not equal to -1, I will print out that element is present at this index and so on. But if it is not present at all, I will return the element is not present. Okay. So what next? This is the main function. Okay. And now I will go through the binary search algorithm, which I have taught you right now. Okay. So I've taken low pointer as 0, high as n -1, and is the last index. Okay. but we don't, array starts from 0 index, so we'll take n minus 1. So we are like running through the loop until these indices cross each other, low and high crosses each other, so mid is low plus high minus low by 2. So okay, while explaining you, I was doing low plus high by 2, but why I've written high minus low by 2 here? To avoid integer overflow. Okay, let's say uh, your low is like somewhat 0, but your high is like crossing the integer value, not crossing, but like your high is like the int max value. And when you do low plus high, it will overflow, and which we don't want, because if we are adding high and low and that high has int max value, then whatever, like if a container is full and if you will add some more things into the container, what will happen? It will overflow, right, and will lead to wrong answers. To avoid that, we use it like this: low plus high minus low by 2. If you try to solve it, it is like same as low plus high by 2, so try writing it like this. Okay, so if my middle element is equals to target, return mid. Otherwise I will check whether my target is greater or not. If my target is greater, I will move on my low pointer to mid plus 1. Otherwise I will move my high pointer to mid minus 1. And if, like, after crossing each other, if they do not find anything, we will return minus 1 simply. Now I want you guys to tell me whether 13 is present or not by this code. So what will you do? You'll just change this target value to 13 and now run this code. Will it work? No, element is not found. It has like worked perfectly fine. Okay, so what if like only one element was present in the array? I will simply write one condition here. If, okay, let's avoid that. Actually, I want to show you. Okay, this is how you can like write array also, and I also wanted to show you the size. And is equals to array dot size. It will take you to that size. Okay, and now we will pass this array directly here, like as a reference. Okay, and now since we have passed it as a reference, we can use if n is equals to 1, then what to return? Return array of 0 is equals to target. So if it is equals to target, then it will return 1, otherwise it will return 0. In this case at least, because I've not used cout cin statements for now for this particular element. So element is not found because our target is 13. Let's say I make my array as 2. Now that we know it will never go inside this while loop. Why? Because it will return from here. That's what I wanted to tell you. That's it. So guys, yeah, that's it. Let's jottle down all my thoughts. Okay. So we have studied this much for sure. Okay. So what is binary search? There is an array. You divide that array into two halves only when the array is sorted. You divide it into two halves and perform operations to find a particular element. That's all. That's what we did. And what is the time complexity of it? It is log of n. So guys, in practical life, it's not really like this. We have some more questions. We have some variety of questions out there. Like a straightforward practical example for binary searches are contact book. We use it pretty much daily. So like you have to call your friend and his name is say Bunny, so you have to call Bunny. So like the binary search will be applied internally, okay, by the contact book or whatever. And now I want you to explore what is monotonic array, and how variety of binary questions are there in the market. Like I just want you to explore. We will also discuss them as well, but there are more varieties of it. And I think, yes, I'm pretty damn sure that you know all these things for sure. And now it's time for a wrap up. So see you guys on the next one. Thank you so much. I really had a pleasure teaching you all. Thank you.